For question 15, given that our y is equal to x ln x, then this question is it by taking logarithm, find the first derivative, and then show this equation. So look at our function here. When we have a x power of ln x, so actually we don't have any function that you can see x power of ln x, because normally our function of polynomial, it will be x power of number, power of 2, power of 3, power of 4, power of something. That will be our polynomial. Or if a constant power of x, that will be the category of exponential, or like 2 to the power of x. Okay, so now the problem is when we have a question where our variable x and then in the power of variable x. So we don't have any definition for this. What is this function? We don't have any rules that can differentiate x to the power of x. Our rules of differentiation just have x power of number, so that power move to the front, power minus 1, or maybe our x in exponential, then we can use our rules of exponential. Salin soalan, differentiate power dia, kalau base dia bukan E, kita kena darab dengan ln 2. So in our rules here, they're only involving polynomial rules and exponential rule. When we have a question x power of ln x, x power of x, so the way we're going to differentiate is by taking ln both sides. We have to simplify this function first, because this function we cannot define anything. So we don't have any rules that can directly differentiate on this. Okay, so this question is quite good because it gives you a hint. They say by taking logarithm, find its first derivative. So from our questions here, y equals to x ln x. So we're going to log both sides. So as we log both sides means we are going to ln y and then ln x power ln x. So how we simplify our situation where x power x, x power x, we don't have that function. So we simplify when we log both sides. When we log both sides, we can use the properties of log that we learned in topic 1 and topic 2. When we have our item, which is in power, our x in power, the rule is the power can multiply to the front. So like we have log, let's say we have a log 3m squared. So the rules of logarithm is when we have our item in power, this power can move to the front. It will become 2 log 3m. So this is our properties of the log we're going to use here. The power of this item, which is ln x, we're going to move it to the front. So it will become ln x times ln x. So finally, we simplify our function here. You can see this is ln x power of 2. Then only we can define our x clearly. This is ln function, this is ln function, x in the ln, so ln function. Then only we start finding our dy dx. So look at our function with that we already simplified here. We have variable y and x, but y is not the subject. Ln y is not in terms of x, y is not the subject because here is ln y. So when we have y in the function of ln, then this question is under implicit differentiation, because y in their function, x also in their function, although this y is writing it at left hand side, but it doesn't mean that this is explicit. Okay, so we're going to differentiate our ln y, our function y here. So to differentiate ln, rules is salin isi perut, differentiate-nya di atas, differentiate y we get 1. Because of variable y that we differentiate on it, we have an implicit factor, we have to time with dy dx. Then for this part, for this right hand side, when you want to differentiate, we can see our function in the power. So we have to use our power rule. Power rule say that power move to the front. Power rule say that power move to the front times this bracket. Then power minus 1, so this bracket will become power 1. Then differentiate inside the bracket. Okay, so power rule we have 3 steps. Power move to the front, power minus 1. Differentiate inside the bracket. Differentiate inside it is ln. So again, we're going to apply the rules of ln. Saling isi pelut ln. X, differentiate di atas. So this is applying on X, so we no need dy dx. When we differentiate applying on Y, then we have to time with our factor of dy dx. That will be the meaning of implicit differentiation. So from here, we have to simplify because they said, please find out dy dx first. Our first task, find out dy dx. Second task, only we go for we're going for showing. So for this dy dx, we just move our y to the right hand side. So it will become 2y ln x over x. Okay, y times 2 times this ln x over x. So that will be our first part of our answer. Then after we done, we are going to show. We have to show up this equation. So again, I repeat, show we have two methods. Substitution method and multiplication method. So from here, since our questions is involving implicit differentiation, then I will use multiplication method. It will be more easier. Or not, you can see if you want to do substitution method, you want to differentiate this again, we have three functions together, variable y, then variable of x, then here linear of x, ln of x, we have three functions together. So three functions together is very difficult to differentiate. Okay, so we use multiplication method. Make sure in one term only have two functions. So when I want to start my multiplication method, I have to multiply until this equation. So in order to multiply until this equation, I need second derivative. I need to differentiate it again. So in order to differentiate it again, I will use this equation, our first derivative in this equation, because you can see in this term, we only have two functions multiplied together. And then at this term, also we have two functions multiplied together. It will be easier to differentiate compared to this function, because this function, we have three functions together. So start from this equation of this first derivative, we write it into the power form. It will be y power of negative 1 dy dx. Then 2 times ln x, then x to the power of negative 1. So we're going to differentiate this more easier. So for our left hand side, it will be function of y multiplied with dy dx, so product rule. So for right hand side also product rule. Two functions multiplied together, function ln and function 1 over x. So therefore, set up our product rule. Salin yang depan, differentiate yang belakang. Salin yang belakang, differentiate yang depan. Differentiate the part that we want. Differentiate dy dx. We get d2y dx squared, second derivative. Differentiate yang depan, y power of negative 1 will be power turun ke depan, power tolak 1 become negative 2, and because this is y, it will be implicit differentiation. You have to multiply with dy dx. Okay, so power turun ke depan, power tolak 1 disebabkan y, implicitly factor dy dx kena buat. Then we move on to the right hand side. Also product rule, but this is in x. Okay, this is our respecting variable. So we set up our rules of product rule. Salin yang depan, differentiate yang belakang. Salin tambah, salin yang belakang, differentiate yang depan. Then we differentiate the part that we want. Differentiate belakang. Okay. Power turun ke depan, power tolak 1. So this is X. We no need write dy dx. Then differentiate yang depan. Okay, differentiate ln. We're going to use the ln. So our coefficient is 2. 2 times isi pelut ln, salin isi pelut ln, X, differentiate dia di atas 1. So this coefficient just carry forward only. Okay, we no need to differentiate the coefficient. So bring forward only. So differentiate this ln, salin isi pelut ln, X, iaitu X, differentiate X, di atas dapat 1. So we done our second derivative. So after we done our second derivative, look at the equation that we want to prove. We have to multiply until this term. Okay, so we look at our equation that we want to show here. We multiply until this part. Okay, so in order I scroll up and down, I will write it. I write it. So take notes that we have to show until this x squared. And then y double prime means d2y dx squared. Minus x in the bracket 2 ln x minus 1. Y prime means dy dx. Then minus 2y. So this is the part. We have to multiply this and then to get the answer that we want. Okay, y double prime. Alright. So in order to multiply until that part, we're going to simplify what we have here. So this is 1 over y d2y dx squared. And then here, negative 1 over y squared, because when we have power negative means denominator here power of 2. And then we can see dy dx, dy dx time together means this factor of dy dx squared. It will be different meaning. This is second derivative. This is dy dx times dy dx become dy dx squared. And then we can see here, we simplify this, it will be giving us negative 2 ln x. Then x power of negative 2 become denominator square. And then this part, it will be 2 over x squared. As we can see here, 1 over x means x times x, denominator here is x squared. So after we simplify here, we compare to our equation that we want to multiply here. What do you need? You need the coefficient of d2y dx squared is x squared, it's not y, 1 over y. So therefore, when we want to multiply here, we're going to time with y and then time with x squared. So that when we time with y, this coefficient y can be simplified, and then time with x squared, we can multiply to get this first term. Then slowly we get other terms. Okay, so that will be our first term. We multiply the coefficient for this d2y dx squared. So once we time our y x squared inside here, we get x squared. And then d2y dx squared. So here will become negative x squared over y. So times y times x squared, denominator can be simplified. It gives us 2y ln x. So this one times x squared times y become 2y only. Then compare the result that we want. So this part we managed to achieve, and then we slowly get 2y. Later on we move it to the left hand side, we also achieve. So now we have to figure out how we're going to achieve this part. How we're going to achieve this part where this dy dx is factorized out, and then this x also factorized out. Remaining here is 2 ln x minus 1 in the bracket. So our next step here, we're going to move this to the left hand side so that it is equals to 0. So when we have multiplication method, means we are going to transform all these, then at the end, straight away the whole equation will become up. That will be multiplication concept. So we transform it, so we need to move it to the left hand side, become positive. Minus 2y equals to 0. Okay, so the remaining part is the middle part here. The second term here, we haven't get it. So how to factorize our dy dx? So this one got factor of dy dx, but these 2 ln x, 2y ln x, we don't have factor of dy dx. So we can refer back to our first derivative. When we have 2y ln x, our first derivative here. So from our first derivative dy dx, which is equals to 2y ln x over x, our equation here, what we want here is 2y ln x. So we move back the x to the left hand side, we get 2y ln x. So for this part, we can substitute it as substitute 2y ln x as equals to x equals to dy dx. So slowly we multiply the second term here. Okay, so lastly we can factorize out. So this is a result. We factorize out our x and factorize out our dy dx. We factorize out our negative x and factorize out our dy dx. So one factor according to our question, one factor they factorize out in the front, another factor they factorize out at the back. So they are same concept, they are factorization concept. So once you take out our negative x here, we will get x over y. So this dy dx already factorized out. Then for this part, so for this part, x already factorized out, dy dx already factorized out, and then negative already factorized out, it become minus 1. So this is square. Okay, I have a writer mistake, square. I'm missing the square. So when we factorize out one dy dx, we still have another dy dx here. Okay, so look at our answer. Where minus 1 we already obtained. Factorize here also obtained. Our answer, this obtained, negative 1 obtained. Try to express the remaining part here equals to 2 ln x. Our remaining part here, okay, so we can use our information from first derivative where we already managed to see x dy dx is 2y ln x. So what we need here is divide by y. So x divided by y for dy dx. So it will be equals to 2 ln x. When our y move to the left hand side, it will become dy. So we will going to substitute x over y dy dx equals to 2 ln x. Equals to, oh yeah, I haven't finished, minus 2y equals to 0. So finally this is the part that we need to show. So is it same? Is it same? Yes. Is it same? Yes. Double confirm. Yes. Minus, minus. So shown.